In this video, we will learn about the explanation of Boyle's law on the basis of kinetic molecular theory of gases. So we know that according to the kinetic molecular theory of gases, number of particles means the molecules present in a given mass of a gas is definite. Also, at constant temperature, the average kinetic energy possessed by the molecules is constant because we know that the average kinetic energy of the particles is directly proportional to temperature. So if temperature is constant, average kinetic energy will also be constant. And according to the kinetic theory of gases, a gas consists of widely spaced molecules moving at random uh, with high speeds, means they are randomly moving with high speeds and they have large interparticle spaces. Now if the gas is compressed in a container, the molecules are pushed closer and thus the gas occupies less volume. Now the molecules, they have less space in which they move and therefore they hit the wall of container more frequently with an increased pressure. So we can say as volume of the given mass decreases, pressure increases, and this is Boyle's law, which says pressure is inversely proportional to volume. So from here we can say what is the practical significance of Boyle's law. So Boyle's law expresses in a quantitative manner that gases are compressible, means if we are increasing the pressure, volume will decrease, means gas will be compressed. Now Boyle's law is manifested in the working of many devices that we use in our day-to-day life, like a tire pressure gauge, cycle pump, etc. Also, at sea level, air is dense because it is compressed by the full mass of air above it. And if we go at higher altitude, atmospheric pressure is lower because air becomes less dense. As a result, less oxygen is available for breathing. So that is why at higher altitude, a person feels altitude sickness, means he feels uneasy or headache. That is why they carry oxygen cylinders with them. Helium-filled weather research balloons, they are normally about half filled before launching. Why? Because if it is completely filled, it will burst at higher altitude as the gas inside the balloon will expand with decrease in atmospheric pressure as it goes up. Now let's discuss some sample problem based on Boyle's law. So we know that P1 V1 is equal to P2 V2 according to Boyle's law. If we cross multiply, so P1 upon V2 is equal to P2 upon V1. So it will help us in solving the numerical problem. For example, here we are having a numerical. 100 ml of a gas is kept at a pressure of 760 mm of mercury. How much this pressure be increased to reduce the volume of the gas to 25 ml, temperature remaining constant? So here P1 is 760 mm of mercury and at this pressure the volume of the gas is 100 ml, so that is V1. Now we have to find out the P2 pressure 2 at which the volume is 25 ml. So P1 V1 equals P2 V2 according to Boyle's law. We will put the values and from here P2 will come out to be 3040 mm of mercury. So here we have seen that the volume is decreased and the pressure has increased. So this is going to be the answer. So I hope it is clear to you. Thank you.